Hello, lovelies. So in this video, we are going to review very quickly how to calculate speed. So speed is the rate at which something moves. You've probably heard it for a very long time, but just to clarify, there are two kinds of speed. There's average speed and instantaneous speed. Average speed is the distance something travels over a period of time. So it could have, an object could be traveling for a long time and have different speeds during that time, but the average speed is it over the whole block of time. An instantaneous speed is a little bit different. It's the speed of something at a very particular moment in time. We are going to be looking at both today. You can calculate both types of speed, using this formula here. Speed equals distance divided by time. Speed is represented by the variable s, distance is represented by the d, and time is represented by the t. You can also use this formula to find the distance something travels if you're given speed, the average speed or the instantaneous speed of the object, or you can find the time that it's taken to travel a certain distance at a certain speed. But in this video, we are only looking at calculating speed. So we're going to do a few practice problems because of course we are. Let's do those practice problems now. So this first one is looking at just average speed here, okay? A snail moves 100 meters in 2 hours. What was this snail's average speed? So I first want to point out to you our formula down here, remember, is speed equals distance divided by time. There's a couple clues that I can look for when I'm looking to see, okay, well, I know my formula, but I need to know distance and I need to know time. So I'm going to look for units. There's lots of different units for distance and time, so we're going to look at a couple. My first one here is distance. Meters is the SI unit for distance, and so that's going to be my clue number one, that this is my distance variable. I can use the verb in the problem as well. So my distance is 100 meters, and I need to know my time variable, right? So I'm going to look for another clue. Hours I know is a time unit, so I'm going to identify that 2 hours as my time variable. Now all I have to do is plug in numbers to my formula. So distance divided by time, 100 meters divided by 2 hours, and just to show you the math, I'm going to show you using the calculator, although this is pretty simple. We don't really need a calculator for this, but so, nope, not 11. 100 divided by 2 hours gives me 50, so my snail's pace is 50 meters an hour. All right, our next practice problem, let's look at that. So this question says, what is the average speed of a helicopter that flies 50 kilometers in 20 minutes and then another 30 kilometers in 10 minutes? So I actually have two distances here and two times. I could find instantaneous speed. I could find the speed at each of these given points in time, but the problem is asking me for average speed. So I'm going to take what this is asking me to find the total distance traveled over the total time. It's the same formula, but we have to do a little bit extra here, okay? So to get my total distance, I have to get all of the distance traveled. So I know this helicopter traveled 50 kilometers and an additional 30 kilometers. So my total distance is 80 kilometers here, okay? Now I need to do the same thing for time. It traveled 20 minutes and also another 10 minutes. So my total time is going to be 30 minutes. Now I just plug in my numbers to my formula. Still have my formula here. So it's going to be 80 kilometers divided by 30 minutes. And we're going to get my calculator out here. And 80 kilometers divided by 30 minutes gives me 2.67 kilometers a minute. So that was the average speed of the helicopter over that total distance and the total time. But like I said, I could still find the speed at 20 minutes, and then I could find the speed at 10 minutes to see how the speed changed or how it was different at each of those times. That would be instantaneous speed. The last problem that we'll look at is instantaneous speed, and remember, instantaneous speed is the speed at certain points in time. So I can use my same formula here to find the speed of this object at point A, point B, point C, and point D. Okay, so what I want you to do is I want you to pause this video and do these practice problems yourself, and then unpause it or play it again whenever you're ready to see me work out all the problems and check your answers. Alright, so you should have paused it, and let's double check your answers, okay? So point A, my distance was 10 meters, my time was 20 seconds. 10 divided by 20 is, I don't think I did that right. That's not right. 10 divided by 20 is 0.5 meters per second. And then at point B, 20 divided by 40 is 20 divided by 40 is also 0.5. Like I said, if some of the math is going to be pretty easy, but it's okay to use a calculator to double check. At point C, it had traveled a distance of 35 meters in 45 seconds. So bringing back my calculator, 35 meters divided by 45 seconds gives me 0.7 repeating. And then at point D, I had gone, this object has gone 65 meters at that point, and the time was 55 seconds. So bringing back my calculator, 65 meters divided by 55 seconds is 1.18 repeating. So what this shows is, even though these are my instantaneous speeds, that it was going these speeds at these particular points, I can calculate my average speed by averaging all of these speeds together. I can also see how the motion changed. I can see that it was going a constant speed for a little while, and then I can see how the speed increased once it got to points C and D. So that's the basics of how to calculate speed. If you have any other questions, make sure you contact your teacher. Bye, guys.